Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is the planet Venus. And here in studio to talk about it is Jonathan Cade from the Warren Astronomical Society. Jonathan, welcome to the program.
Thank you, Don.
So, why are you interested in Venus?
Well, Venus and humanity has quite a bit of history. Venus is the planet that helped Galileo confirm the Copernican theory of the solar system and show that our planet was only a satellite of the sun. Using Venus for the transit allowed us in the late 18th century, in the late 17th century, to determine the distance to the sun from the Earth. And basically, watching Venus over the years has allowed us to figure out what other planets look like when they're going in front of other stars. That teaches us a lot about exoplanets. So Venus is also probably has a fairly similar history to the Earth, and given the current state of things on Venus, it might tell us some really important things to know about the planet we live on and what could happen to it. So I've always been fairly interested in Venus, and starting with the transit of Venus in 2012, I got super interested.
And we've got one coming up in November.
Well, we have a transit of Mercury, yeah.
Oh, it's Mercury, that's right.
That's right. So unfortunately, none of us are going to see another transit of Venus. The next one won't be until 2117.
Yeah, we had two 8 years apart.
Yep, 2004 and 2012, yep.
Now,
I missed the first one.
What we've learned about Venus are by space probes. We hear about Mars a lot, but not so much about Venus and probes.
So a lot of people seem to think that we haven't really been to Venus. Well, Don, do you happen to know offhand how many times humankind has sent probes to Venus?
No.
So, believe it or not, if we have this graphic, we've gone 43 times, and we're on our way for the 44th time.
So, is that right?
That is right. And so we've actually visited Venus a lot more than a lot of people think. And many of those haven't quite worked out, but many of them have been successful. And I think one of the reasons we don't hear about it so much is that a lot of the successes were with the Soviet space program. And of course, they didn't tell us too much about what they were doing, and we learned about it after the fact, but they got there 15 times and we've only gone 10. So that could be one reason people haven't heard about it so much.
Now, it would seem hard to get something to Venus and maybe even on the surface. When did the first probes arrive?
So, believe it or not, now we think about Mars as being a natural place to go, but Venus was the first planet outside the solar system, outside the Earth-Moon system that we tried to get to. In 1961, already the Russians are sending probes there, and the US followed soon after in 1962. Now, the Russian Venera 1 craft actually flew by Venus, but it was dead on the flyby, and the US Mariner 2 craft was the first one to actually successfully get there. And honestly, the Russians tried really, really hard in the early years, and they kept failing over and over again. The Russian space program didn't really believe in testing, so they would have problems like they would get into near Venus, and then they would discover the probe was dead because it couldn't handle the G-forces of the launch. So it took them a while to actually get to a state where they would be able to do some serious science at Venus.
Now, all of these early probes, were they just orbitals or flybys?
So the American probes concentrated on flybys and orbiters. The Russians started trying to get into the atmosphere pretty early, and with the Venera 4 probe, they succeeded in actually getting it into the atmosphere and taking some measurements. The American Mariner 5 craft actually was able to do serious science. It was a reused Mariner 4 craft. It was sort of the body double of the Mariner 4 craft that went to Mars. And it was able to show that there were no Van Allen belts around Venus, and it took detailed pressure and temperature readings. So all of these early missions, and including the Soviet Venera 5 and 6 missions, they essentially just kept confirming the prior temperature readings and pressure readings and moving that decimal place a little further and getting a better idea of the temperature and pressure. But they weren't able to do very complicated chemical studies. So we learned pretty fast with Mariner 5 that Venus was not a very pleasant place to be, and that did kind of take the shine off the apple, and that's why we kind of focused most of our energies and most of our emotions towards Mars.
I recall a student in school back in the day, the prevailing thought then was Venus is just like Earth, just a little bit warmer.
A little bit.
Yeah, and it seems that these early, flybys and orbiters just really dashed that thought all to pieces.
Yep. Yeah. Even with Mariner 2, we basically figured out that the temperature on Venus was about 900 degrees Fahrenheit, and later on we would learn about all the sulfuric acids. So the Russians successfully got a probe to the surface of the planet in 1970. So the Venera 7 probe actually got to the surface, survived. They thought it failed, but what had happened was it actually rolled over when it landed and the antenna wasn't pointed back at Earth. But they were able to actually get some temperature readings from what the weak signals they did get back. Venera 8, which was a similar design, did successfully land, took wonderful measurements, was able to figure out that there were different cloud layers, and really started teaching the Soviets a lot about what Venus is like as a world.
And so they had the early edge on getting a comprehensive knowledge of Venus and its atmosphere?
Yes, yeah. So definitely the U.S. After Mariner 5, like that was our big early mission. Mariner 10 came by on its way to Mercury on the first incredibly successful trip to Mercury.
Yes.
And it took a wonderfully beautiful picture that continued to be used in textbooks for years to come, but it didn't really do a lot of science. It was just a flyby and just a gravitational correction. So
okay, use it as to adjust its trajectory there.
Yeah, but the Soviets kept going back, and they kept getting more and more ambitious. Like they didn't just want to take pressure and density readings. They wanted to actually figure out if they could do surface photography, and in 1975 they actually succeeded. So we knew that they did. They published photos from the surface. They kind of looked like they came out of a fax machine. They're very high contrast. They don't look very good. An American researcher named Don P. Mitchell, he took those photos. He was able to get the original data that came back from the probes and reprocess them, correct all the errors, figure out what was wrong with each line in the original data, and produce a photo that looks almost as good as modern displays can show. So it's really impressive what he was able to do to take these very high contrast, ugly photos and turn them into really beautiful views that let you imagine actually being on that planet, even though they were black and white.
Yeah, as we can see on the screen right now, it's looks like it's just sort of shooting down at its feet.
Yeah, so for whatever reason, it's hard to build a craft that's going to survive in a 900-degree sulfuric acid bath. So you have to give the Soviets some credit. They were trying to build the camera in such a way that they would be able to photograph around without having any part of it too exposed and too far away from the heavily shielded body. But it is pretty disappointing with the early photos. There aren't very many photos, and so many of them are just focused on the ground right around the feet. There's only a couple of photos that really give you a sense of what the horizons to the distance look like.
Get more of that panoramic view.
Yeah, so with the next set of successful Venera landers, they were able to actually do a high-res view of the Venusian landscape, but we'll talk about that in a minute.
Okay, well here I can see a first map taken from our Pioneer mission back in the later 70s.
Yeah, so the Americans had not completely given up. The Russian approach was to send mission after mission after mission there, and each one built a little bit on the previous one. The American approach was to more build these huge programs, usually involving multiple craft, and try to do everything at once, because I guess it was easy to get it into the budget, where in the Soviet Union you could just have the Soviet Politburo tell you to spend the money as you needed. But so with the Pioneer Venus orbiter, we actually orbited the planet and we mapped somewhere around 85% of the planet in detail. And those were the best maps we had of the Venusian surface for many years. And
were those done in radar?
So those were done in radar. They didn't have quite the same level of ability to do chemical analysis remotely using spectroscopy that would be possible later. And of course, they have to get through these incredibly thick clouds. We also wanted to know what the clouds were like. And so we had the orbiter, which was Pioneer 12, and the second part of that mission was Pioneer 13, which was a Venus multiprobe. And that was our first attempt to land, to get into the atmosphere and to see if we could survive to the surface. And yeah, I think I'd like to talk about that in a minute.
All right, well, we're going to take a quick break. If you have any questions about this topic, about Venus or any other, you can send us an email. The address is down at the bottom of your screen. And right after Term of the Month, we'll be back with more of this discussion about Venus. Stephen?
The term of the month is infrared spectroscopy. Infrared spectroscopy can be used for absorption or reflection to identify chemicals and or temperatures. Now, there are three ranges of the infrared. We have the near infrared, so that's near the red part of the visible spectrum. And then we have mid infrared, which is longer wavelengths than near infrared. And then far infrared, which is that much farther, much longer wavelengths. And it's in fact next to the microwaves, just like in your oven, but starting a little shorter first. Now, the near infrared is good for molecular vibration, but it's the overtones that you're talking about, the harmonics. Mid infrared is good for rotational vibration and structure. And then far infrared is really for rotational spectroscopy, but also temperatures. So, OSIRIS-REx had an infrared spectrometer on it when it visited an asteroid fairly recently. So the aperture, the opening for the camera is on the left, the lower left there, and the rest of it is basically a camera with the spectrometers and so on inside. So this was aboard the OSIRIS-REx spacecraft. Venus Express has had an instrument called the PFA, the Planetary Fourier Spectrometer. Say that 3 times fast. And it was used to look at the far infrared to the mid-infrared range. And so it was used to sound the atmosphere. That is, it would find the temperatures at different elevations in the atmosphere, so heights above the ground, so that it was able to find a 3D temperature field. And so it searched for minor chemicals for the most part, but these temperatures and the exchanges of the temperatures with the surface. So that is the term of the month, infrared spectroscopy. Back to you, Don.
Thanks, Stephen. We're here talking about the planet Venus with Jonathan Cade from the Warren Astronomical Society. So, Jonathan, can you tell us about some of these probes?
Yeah, so as we were talking about, the Pioneer Venus multiprobe was this amazing sort of transformer. It was like a seed pod where it had this bus with all of these electronics and all of this stuff that it could measure from orbit, and it dropped all these little seed pods that went into the atmosphere, and they went to different parts of the planet on the dark side, the night side, the day side, and then on the border between darkness and light, measured temperature, measured pressure. And one of them that they didn't expect to live actually survived on the surface for an hour, which was longer than any of the Soviet probes had lived for that long.
That's pretty amazing.
And then the whole bus that was doing all this stuff from orbit came in after it and actually burned up in the atmosphere, but it measured a lot of stuff on the way down. So mostly, the most important thing they found out was that the balance of different isotopes in the atmosphere were different than Earth. So definitely Venus did have a different history than Earth did, and that gives us some hope that we're not going to follow too close in the same pattern that they followed.
Good to know. What about some other probes?
So in the early 80s, the same year I was born, the Soviets decided they wanted better pictures, and they actually sent probes that were able to take higher resolution photos that give you the kind of photos you want, where you have
was waiting for the
mountains,
pretty pictures.
yeah,
Exactly.
mountains in the background. You can see you can get a sense of what the atmosphere would be like behind it. And then on top of that, the same probes were actually able to take some color photos as well. And the color doesn't look super good. You can kind of see a little blue, you can kind of see red, but mostly you can tell Venus is a very yellow planet. So it's definitely not, it may be magnificent desolation, but it's definitely a very sulfur-colored desolation. But it's really awesome. Don P. Mitchell was able to get the raw data from the Soviet scientists and just do amazing stuff to restore it and really give us a sense of what it would be like to be on that world. And these are the last photos that we have from the surface, so I think they're really precious.
They are. Those are truly, truly amazing. Now, talk about landing on Venus in the later 70s into the 80s. Are there any additional landings during that time? Or?
Yeah, so everyone remembers Halley's Comet.
Sure.
So actually, I should say the Soviets actually wanted to catch up with the Pioneer Venus orbiter. So they wanted to map the surface with radar too. And so they sent a probes, Venera 15 and 16, and those probes took extremely high resolution radar images of the planet, but they were only able to get 30 degrees down from the North Pole, so they got a lot less of the planet than we did. But they did get a part of the planet that we didn't at the North Pole. So it's kind of impressive what they were able to do, but they clearly wanted to send more probes that they never got to send. And again, this photo was processed by Don P. Mitchell from the original data, and he was able to get amazing data out of it that had never been published before. So his website is mentallandscape.com. Definitely check it out. There's tons of great stuff there.
So with the troubles the Soviets had, did they continue?
So you may remember Halley's Comet. So in 1986, they wanted to stage a mission to hit Halley's Comet. And on the way, since they're visiting Venus all the time, they figured they would land something on Venus and actually do some atmospheric studies with balloons in the atmosphere of Venus. And so they didn't have such a great time with their seismology earthquake experiments. They went off when they were still in the air, so you can't really do earthquake studies when your probe is in the air. But the balloons actually survived for more than a day, and they actually covered about 30% of the circumference of the planet, which is pretty amazing work for something that's pretty cheap and pretty simple. So
Yeah, indeed, indeed. Now, I seem to recall Magellan.
yeah, so in 1989, so basically the Soviet Union fell and the Soviets and the Russians stopped going to Venus entirely. The US actually did go back in '89. Believe it or not, the Pioneer Venus orbiter is still alive, and the two craft worked together to map Venus to an amazing extent. Magellan was able to take high-resolution surface views of 98% of the planet. It was able to do high-resolution gravity maps of 94% of the planet. And that is what actually is the data from this globe, and it's just amazing what they were able to do. And it survived for 5 years. Not quite as impressive as the 12 years that Pioneer Venus orbiter was there, but it gave us these amazing views of a planet with mountains and other stuff going on.
Yeah, it's this shot right here. I just think is totally amazing. It's talk about the totally alien world. Yeah.
Yeah.
So are there any other missions planned? I mean, that was quite a while ago. We were talking late 80s, early 90s.
Yeah, so we had this dry spell where all anybody wanted to use Venus for was gravity assist. So Galileo swung by, Cassini swung by, Messenger swung by, and Messenger took some photos of Venus that show Venus as a crescent receding in the distance, but none of them did any science. So I call those the chopped liver years. We only cared about Venus because it helped us get to other places. We didn't really care.
It was a means to an end, sure.
Yeah,
Gravity
exactly.
assist. Sure.
But the European Union actually went to Venus next, and they went with Venus Express in 2006. That survived for a good 6 years and did really good atmospheric studies. And so that, at least there was something there in the 2000s.
Again, all atmospheric orbiting
Right.
missions.
Yep, and no one has gone back to the surface or into the atmosphere since the Soviets. What's really interesting is that Japan's space program, which does amazing work on what seems to be, you know, a smaller budget than we have, they actually went back in 2015. They had a terrible disaster where the main engine didn't turn on, and they had 5 years after it flew by, they were able to nudge it into an orbit and take amazing photos and atmospheric studies. So
Interesting, interesting. What is NASA planning?
So actually, NASA doesn't have any firm plans. India is planning to go, I think, in 2023 with the Shukran-1 probe to Venus, and that's going to be amazing. The Russians are still working on Venera D, where D is the Russian word for long-lasting, and that has been, they've been working on that for about 10 years, and it's not supposed to launch for another 8 years, so I don't know if that's going to happen.
I thought the mission was long-lasting,
yeah,
not the process.
Yeah,
to
the
build
process
it.
is definitely
Yeah.
long-lasting. But in the Glenn Research Center in Sandusky, Ohio, they're actually working on studies of how to make stuff survive in the Venusian atmosphere. And there are a lot of people on the Venus Task Force inside NASA who are working on amazing projects like cloud-top drones that can fly through the clouds and fly through the atmosphere for a long time. And those cloud-top drones are a great idea because it's much easier to stay alive in the clouds of Venus than it is down at the surface. And other projects that people are interested in doing are having a rover that goes on the wind on the surface, which you still have a lot of problems to solve, and even a clockwork rover, so a totally mechanical rover that doesn't have any electronic parts, so it can survive a lot longer, that basically has a little disk that you can beam radar at from orbit and get data back. So I don't know if that'll work, but it's a super cool idea. And I don't know what will work, but I know that we need to go back to Venus.
It's an amazing place, and I agree. We need to learn more about Venus. So hopefully NASA will get us back there.
So I just read today, in fact, that the task force encouraging Venus study is really fighting hard inside NASA. It's really close to us. It's really easy to get to. It's not that hard to deal with gravitationally. There's a lot that we can do there on a shoestring budget, and we really ought to spend the small amount of money that it would take to do some new science there.
This sounds truly amazing. I want to thank our guest, Jonathan Cade from the Warren Astronomical Society, for talking with us about our sister planet, Venus. Please visit our club website. We like to have folks visit, and we have the address down there at the bottom of your screen. And to finish off our program, we have What's Up in the Night Sky with Stephen.
Thanks, Don. What's up in the night sky for November 2019? The days are getting shorter. The sun rises at 8:06 to 7:41 in the morning over the month, and sets at 6:27 to 5:02 p.m. That's in the northern hemisphere, Michigan area. Add an hour and 40 minutes on either side for astronomical night. The moon starts off in first quarter on the 4th, full moon on the 12th. The 19th gets you to the third quarter, and new moon on the 26th. Mercury is in Libra all month. It sets at 7 p.m. at the beginning of the month and rises at 6 a.m. at the end of the month. That's because we have inferior conjunction, which is accompanied by a Mercury transit, not to be missed if you can get it, on the 11th of November. So first entry, that's when Mercury enters the edge of the sun, is at 7:36 a.m. That's Eastern Time. It's in the center, or as close to the center as it can be to the sun at 10:20. So it's a long event, again Eastern, and it exits at 1:04 p.m. Eastern. Don't forget, you're looking at the sun mostly, so use a solar filter, all of the techniques you use for looking at the sun. Back to Mars. Mars is in Virgo, rises at 6:22 a.m. to 5:06 a.m. It's a little better at the end of the month where it's farther from the sun. Superior conjunction was October 8th, which is why it's a morning object. We move on to Venus. Is in Scorpius to Sagittarius over the month. It sets at 7:20 p.m. to 6:41 p.m., so it's better at the beginning of the month. It's farther from the sun. Jupiter is in Ophiuchus to Sagittarius and sets 8:48 to 6:20 p.m., so they actually cross. Saturn is in Sagittarius, sets 10:26 p.m. to 7:44 p.m., and Pluto, need a good 10-inch plus telescope for that, is in Sagittarius also, sets 10:50 p.m. to 7:59 p.m. And then finally, for the planets, we have Uranus in Aries. It sets 7:45 to 4:46 p.m., and it's better a little bit at the beginning of the month. But really, since opposition was October 28th, this is another month where you could try, when it's really dark out and you've got a good sky chart, to see if you can find Uranus, or see it anyway, naked eye. And then Neptune is in Aquarius, where it always is, and sets 3:37 a.m. to 42 minutes after midnight. And that is what's up in the night sky. Remember, we don't charge for this show, but we may tax your brain.